Hello, welcome to this session of our revision for the GCE. Today we are going to be focusing on ordinary level physics paper 1, and we are going to be looking at the paper of June 2017. In particular, you should pay attention to the tricks that will be used in answering these questions. So here we are with the first section of the paper, which consists of 42 questions. The directions are that each of the questions or incomplete statements in this section is followed by 4 suggested answers. Select the best answer for each question. So in the first question, a couple can be defined as A, the product of a force and the perpendicular distance from the pivot. This one is simply the moment of a force, not couple. And B, the product of the perpendicular force and the distance from the pivot. And C, 2 equal forces acting in the same direction. And D, 2 equal forces acting at different points in opposite directions. Yes, that's the best answer that defines a couple. And generally in everyday life, situations where you could constantly apply a couple is in the case of the steering wheel of a vehicle. So when a driver is on the steering wheel, he is applying a couple, because at any instant, so long as he's holding the steering wheel with 2 hands, he will be applying a couple, a pair of equal but opposite forces. You also have the case of opening a tap. When you are opening a tap, there is always a couple that you apply. In number 2, which of the following properties of a solid would change if it were transported from the Earth to the Moon? So generally what you should understand is that even on the Earth's surface, gravity, gravitational force, or the gravitational pull, the acceleration due to gravity, would always change from one point of the Earth to the other. For instance, it is less at the equator than at the poles of the Earth. And the same thing occurs when you take an object from the Earth to any part of the universe, including the Moon. So when you take an object to the Moon, the acceleration due to gravity will reduce. The gravitational pull on the object will reduce. And since weight is a measure of the gravitational pull on an object, we expect the weight of the body to change each time it moves from one part of the universe to the other. The other physical quantities like the mass, the volume, and the rest, surface area, density, and so on, they will all remain the same. Only the weight will reduce due to reduction or increase in gravitational pull, depending on where the object has been taken to. In 3, identify the pair of forces that are all non-contact forces from the pairs below. In A, weight is a non-contact force, but upthrust is the force that is applied when an object floats, either in a gas or in a liquid. So the floating of objects in fluids generally would lead to an upthrust force, which is counteracting the weight of the object that is floating. And so upthrust is a contact force. Frictional force is a contact force, of course. Friction can only exist between two bodies that are in contact. Electrostatic force is a non-contact force. Air resistance is a contact force. There must be contact between an object and air for air resistance to be exerted. And for tension, we also have that it is a contact force. But in D, magnetic force and weight, they are all non-contact forces. So the correct option is D. In number 4, compensating for friction on a runway means reducing frictional forces to 0, raising one end of the runway. This one, raising one end of the runway, is the way it is achieved. But they are asking for the meaning. What does it mean to compensate for friction on a runway? So that is achieved by raising one end. So raising one end is not the meaning, it's the way that is used to achieve that compensation. C, adjusting the runway to balance friction with an equal but opposite force. Yes, usually on the runway, the experiments usually seek to give a trolley that is running on it a uniform velocity, and that can only be achieved by providing a component of the weight of the trolley that will just balance the friction on the runway. In number 5, a trolley of fixed mass undergoes an acceleration of 5 meters per second squared when a force of 15 Newton is applied. Assuming no external force acts on the system, what force will give the trolley an acceleration of 3 meters per second squared? So this is the case of the relationship between force and acceleration, which is direct. So there is direct proportionality between force and acceleration. And to do this calculation, then we make a mathematical representation of that relationship. The fact that the first force divided by its acceleration will always be equal to the second force divided by its acceleration. That is the mathematical representation of any two quantities that vary directly. that the ratio of the quantities at any one time would always be the same. And so F1, which is 15 newtons, divided by its corresponding acceleration, which is 5 meter per second squared, must be equal to this next force, which we're looking for, divided by its acceleration, which is 3 meter per second squared. So these units will normally cancel, and we can cross multiply. So we have that 5 F2 should be equal to 15 times 3. And when you divide through by 5, F2 should be 15 over 5, which gives 3 times 3, which is 9 newtons. So the force when the acceleration is 3 meter per second squared would be 9 newtons.